Hello, so I'm going to talk about SQL Server temporal tables. These allow us to have some inbuilt auditing capabilities within SQL Server. So if you make a modification, an update or a delete, this is actually tracked. And this is something we can implement in SQL Server fairly easily, really. And then I'll show you how you do that and then how we also query the data. So let's jump straight into it. So in this case, I've got a database called Playground. And we will create a temporal table. So the important thing to note is it's a normal table up until this point. The temporal table syntax kicks in here and the last line here. So in this case, we've got an employee table with an employee ID, a name, a department, a salary, a modified by, and then we've got a sysstart and a sysend. So sysstart has this syntax of generate always as row start, so that's our starting one. These are used to track the start and end date where values exist, as I'll show you. It's also hidden, so it's not shown by default. And generate always as the end for the end date, and that's hidden. And then we've got period for system time, and we pass in those two new columns we've added here. Note that it's a date time too. You can make it more accurate. I've just kept it to a less accurate format, to milliseconds I think, but not nanoseconds or whatever. We'll see those. I've got an index on it which takes the employee ID, the start date and the end date. This can be useful for seeking to a point in time to figure out what the value maybe was, maybe a salary that this employee was on. And finally we've got with system versioning, and this actually says implement the temporal table and have the temporal data stored in this employee history. So it'll create this table, but it will also create this one. So temporal tables are like two tables, but within SQL Server you'll see what they look like. They look a little bit different. So if we run that, if I now open my Object Explorer, refresh, you see this is a temporal table. So it looks different than some of the other tables I've got in here, like a user. I've got it's DBO employees, but it's got system versioned after it. If you open that up, you'll actually see the employee history table below that. So our primary table's here, but as we do updates and deletes, they'll get added to this table here, and I'll show you that all now. So like normal, we can just query the table. So we can query the employee table. As you can see, it's empty because we haven't added anything. So what we're going to do is we're going to add some data. So in this case, we're going to insert some employees with a few people's names, their salaries, and we're just turning the identity off so we can insert them. Then we put the identity back on. So let's run that. So let's see what's in the table now. So if I execute this, we see some employee data. So note we don't see the sysstart and sysend because these are marked as hidden. So if you remember up here, they've got this hidden syntax. And by default, when you do select star, you're not explicit about the columns. It will not show hidden columns, which is quite useful in this case. So in order to show them, we can run the following by explicitly asking for them. So if we explicitly ask for the columns, like this, what we get is a sysstart and a sysend date. So if you look at the Object Explorer, you'll see that I'll open this up again. You'll see that it's marked as a system version, like I said. We can select from it if we want, but you will see that there is no data in it as we have not modified. So yeah, if we go and look at the history table I'm talking about underneath it here, and we run this, let's see if we've got anything, and we haven't got anything because we've not made any updates or modifications. We have got data in here because this was the first insert. So let's do something now. Let's delete a row and then select all rows. You will see that the employee with ID 5 has been removed as expected. So if we delete employee 5, this Robert fellow here, run those two, well, delete, yep, and then we select, we see row number 5's gone. Now let's look in the employee history table. So what do we see? we see that this table now has the row that was deleted. So row 5 is now inside here. Okay, so we're starting to see things happen now. So it's gone from employee and it's gone to employee's history. So let's update a row where the department is web dev. So imagine we get an update that comes in. Let's have a look what's in that table at the moment. This is going to update the employees, increase the salary by 0.5 of 5%, I believe, and the modified by user 2. In this case, they're all user 1, where web dev. So this user here, number 1, their salary should be multiplied by 1.05. So if I run that, if you remember before, I think it was 1,000. Now it's 1,050. So, and we've got a user 2. So if we look at the hidden fields, you will notice something different. So yeah, let's run this. We're including the columns. So the sys start for the web dev we changed now has a larger date. This is important to note. So it's saying this is different. Yeah, all of these are initialized with default values when it was created. This is when it was maybe removed, so the end date, but the thing to take out to this one, we've modified it, so the date is now 6 o'clock. Yeah, it looks like 6 o'clock, whereas these were done a minute earlier. Yeah, 58, 2 minutes earlier. So again, let's have a look at the employee table. What do we see in there? So if we run this, what we see now is there's a row for the one we modified. So we can see that the old value of the web dev is stored in here. So you can sort of see the auditing coming in now. Here's web dev. This one was 1,000, but you remember it went up to 1,050. User ID. It was treated as a delete and then an insert. So it moves the old version with the sysend set to the transaction time that this was done. So you'll notice it now has a start and an end date. So it was created at 17:58:07. It existed at this value until 6 o'clock. So something changed within this period. This was the data. But as we know, we've changed that in the employee table here. I'll get those columns as well. And we can see now that's from 1640 to the end of time. So this is the newest data. Okay, so let's update the same row again. This time we're going to multiply it by another 5% and we're going to change the user ID to 3. So if I run that and then we look at the employees, what we see is, yep, salary's gone up again. User 3 is now in there, so it's all updating fine. These are just normal SQL operations you would do. We're not doing anything special. And again, let's have a look at the start date and end date. If we look at these now, we can see this has existed from 6:02 to the end of time. So we're starting to see how this start and end date come into play. Okay, so it will treat it as a delete, as I said before, and then insert it. This time we see that we have 2 entries. Okay, I'm jumping the gun, but I'll call that. So yes, now our original value was this one with 1,000. That existed from 17:58 to 6 o'clock. We then had a change. You'll notice that these numbers are exact because that's the time period. Then something changed, and then it was that value for 2 minutes. So you can sort of see a history now. This was the first one. This was the second one. It's not usually recommended to just query the history table, as SQL Server provides a cleaner mechanism to do the querying, as I will show you. So as usual, your code can continue to query and change the employee table, happily not knowing about the hidden fields and the temporal table stuff. Firstly, if you want to get a snapshot at a point in time, you can do the following with the system time syntax. Change the date to be something in where we can see a previous state. So yeah, I need to now modify these on the fly. You can see the last time I ran this. So today is the 10th. So what we want is we want a date. So if I wanted to get for a specific time point in time, get me the value for that employee. I can pass in something between, let's go there, 17, 10, 11, 10, let's go 1759, let's go 1759 and see what that returns. So what we see is for 1759, these were the values. So this one, yeah, was 1,000. So if you remember, actually, if we select from here, you'll see, actually, the current value is 1102. But at this specific point in time, we're now querying for that value. So it says it's 110250 with user 3, but if we say at this time, what was the value, we can see at this time for this user, it was 1,000 and user 1. So you can see a sort of, and we didn't do anything special, we didn't write any fancy query really, we just said using the system time temporal table functionality, get me the values for that time. So this could be really useful, you imagine, for pricing or something like that, where you want to know the price at a certain point in time. So with this, we could create a query to compare salaries between two dates. Select the first date as something just after the date that it was inserted, then the second date can be something in the future. So I'm going to take this date, forgive me if I get this wrong, because I forget it's at this point in time. So if I maybe make that 1801, let's see what that gives me. Okay, yeah, so here we've calculated the salary increase between that time. So between that time, these are small times, but you could imagine it months or years. You could say, okay, well, this employee at this time was earning this much. So this is T1. So we do T1 salary. It looks like we're minusing, well, doing some maths, percentage maths, basically. But what we see, the end result, is that if we join on itself, but for a later date, we can get the values, the old values, the new values, and work out. And between this period, we got a 5% increase. If I change that to a 3, because I think that's outside of that one, we'll see actually, so in that period, their salaries increased by 10.25%. So if you want to return a range of data and changes, you could run the following. So this I can see is set to the end of time, which is good. Let's just run it and see what happens. Okay, yeah, this works. So we've gone from a date in the past to a future, and what this is doing is it's saying get all the values. So we can see here that this has changed over time. The first value was that, then it was that, and it's currently that. And you'll see with the times, this is when it was created, this is when it stopped being, it was deleted and a new row came in. This is when the next one came in and it existed for 2 minutes. And finally the latest row here was created at 1602 and it's existed. You can tell that these are the latest rows because they've got the end of time value in them. So that could be quite useful. The rule for so there's different rules now. I'm not hugely clued up with them, so I'll just show you them. So the rule for this, from and start and to and end, these are all the syntaxes you can use. This is returned the same data. But notice we're querying this table, but with the system time it knows to work with the history table to figure it out. We generally don't want to directly query the employee history table. We should better off using this syntax. There's a rule for between. So here we've got for system time between and then this seems to return the content of the history table only. So if we run this one, yeah, we can see that. So this row we deleted. This was the first row that was changed to this. This row was then changed to another value in the employee table. So this shows us everything that's in the employee history table. There's a few sort of things I've commented on, but you can learn the syntax and have a play with it. You can also return all the rows as follows using the all clause. Okay, so we're using an all clause here. If we run that, yeah, we see all our rows 1 to 5. That one's deleted. These are the historic ones. So with this knowledge now, you can see when we make updates or deletes, we're getting a free bit of auditing every time, which is really useful. With this knowledge, we can see that we can display an audit of what has changed. Here we can see that we display a list of changes done to existing orders. Note that this does include the deleted. So if we do this one for system time between, let's see what that gives us. So yeah, it's giving us all the records. And again, as I said, you've got a time span. This is the other way, from there to there, then from there to there, then from there to there. For this one we've used. We also see the deleted one. You can also tell it's deleted because it hasn't got a sys end date of the end of time, and there's no row to replace it, so we know that that's a deleted row as well. So to show non-deleted rows, then we might do something like this. We can use an inner join to only show for items in the employee table. So we're looking at the employee table, and yeah, so anything in this table, and we're using an inner join, so any deletes won't be shown. So if I run this, we can see row 5 isn't there. Because of the inner join, the deleted row isn't in here, so we're not going to find it in there. So what we can do now, we're going to clean up the table. So temporal tables are a bit harder to delete. You see, I can't delete it. What you have to do is alter the table, set the system versioning off, and then you can actually drop them. And so I'm going to run this, but I'll actually show you a bit more, because people have to do this. You know, maybe if you're testing and you've got lots of employee history data in there that you don't want, you want a clean slate. We can run this. I could run it all if I want to just drop it, but I want to show you. So if we turn this off and then I refresh this, you'll see that now our table is split. We've got our original table and our employee history table. So now I can do normal SQL things like truncate this employee table if I want, an employee history table. I couldn't do that before because it was bound with a temporal table. I could do that, and then I could re-enable it, which I'll show you further down. All we do is this syntax. I'll come back to this again, but we're altering it, setting the version on. So if I click that and then refresh it, you will see that, there you go, it's back to a temporary table. But I'll go into that. So that all you need to do is turn off the functionality, and then you can do your normal operations against the table. Once you're done, for example, we wanted to truncate our data or clean it up because we had a lot of test data auditing in there. You want to turn it off, do your clean up, truncate the table, and then you re-enable it with this syntax here. So I'll carry on. I'll just run this to remove it. This table should now be gone. Yep. So let's move on to the next bit. So you can also make an existing table a temporal one. Let's imagine the employee table has been around a while. So here's our employee table. I'll just create it, I'll populate it, and I'll select from it. So here's our employee. If I refresh this, it's just a normal table. It's not got the temporal table syntax. So note that we have made a normal table with nothing special. Now let's add the temporal table functionality. So like before at the top, we're going to alter this table. We're going to add a sys start date, a sys end, and the same syntax as before, period, telling it these two columns are used for this temporal table functionality, and then finally turning it on. So we alter the employee table, system, set the system versioning on, and then say use this employee table. We haven't got the employee table, it will create it for us, but we can, if the table does exist, it'll just use that one. So back to this one, the syntax is a bit different. We've got the row start and row end, it's hidden, but we have to add some default constraints because these columns never existed. So we make it not null, and we give it a constraint name of df employees, sys start, and we set the start time, all intents and purposes, to the beginning of time, 1900, first of January 1900, and then the end of time. So these then give us a window where temporal tables can chop and change and basically generate the data that you saw before. So let's run this. If I refresh this now, you'll see it's back to a temporal table. So that's how you would add, if you've got an existing table, you can do this to make it temporal. So you'll now see that the employee history table has been created as before. Let's go and, looks like we're going to update something. So let's actually look what's in there, make sure. This is saying it's going to multiply the salary for Peter. So he's on 2,000. Let's run that and then let's look. So yeah, Peter's gone up by 4,000. Okay. Here is a query that lists the changes for the employee with the name of Peter. So we're selecting all of them, explicitly asking for these columns. I'll try and sort out the formatting. We're going to select from there between this beginning of time, end of time. Basically, I don't think we care as long as it's in there. Let's execute that. So what we see, yeah. So Peter, we can see from the beginning of time to here, he was on 2,000. Something happened from 1615 to the end of time where it was 4,000. So what happens if we add a new column? So now you're like, oh, but I need to add a new column to this. So we can do that just with usual SQL syntax, alter the table employees, and we're going to add an age column. So let's run that. Okay, it's been added. Let's select from it. We can see the age is now null. Let's update some things. So update the employee, set the age, and update the, okay, so we're going to do two updates. We don't run these together, otherwise we won't see the increments. You'll just see the 39. I've done that before. So yeah, run this one. Okay, then run this one. So we've changed the age from 38 in one transaction, then we did it again to 39. So what we've got here is a query to look at that data. And what we see is, so we've got 38, 39. So we can see beginning of time to there, we had all this data null. Then something happened between 1816 and 1817 where the age was changed to 38. We can then see the current value, which is from 1817 to the end of time. We can see 39. So I'm not sure what this is doing, but we can, yeah, well, this is just showing you that's in the temporal table at the top, and that's the data in the bottom with everything. So as you can see, it's really useful. So what you're getting out of the box just by turning temporal tables on is free auditing, really. You don't have to create your own audit table and update, delete, and do all of that. It's all done for you. Then I do get asked, what about performance and things like that. I don't think the performance is an issue. I think it's the size of data. I've not tried it on millions of rows, or I've used it for employees or user tables where there's a couple of thousand rows, maybe tens of thousands. So you'd have to go and test it yourself against 100,000, a million rows. If you're going to have things changing a lot, then your history table may get rather big, but you'll have to look at that. But getting something free like this out of the box, I think, is really useful. And I've used it in several places over the years, so it's really useful. So what's this final comment? We see that this is fine, and we now get that in the employee history table. So we've gone from creating a temporal table from scratch, a new one, looking at an existing table, and adding temporal table functionality to it. We've also looked at adding a new column as well. We've added an age column that didn't seem to be an issue, and we've seen the syntax of seeing sort of a timeline of the values. You can see how they change, but yeah, and there's some useful syntax in here if you want to, like the one where you want to just find a specific point in time. That was really useful. You can go, okay, what was their salary on January the 1st, 2023, And you can do the maths with, like I said, inner joins on things to figure out, in this case, what's the percentage, the salary increase. So yeah, that is temporal tables basically. Really quite nice. I believe they were introduced in 2016. So yeah, give them a go. They do require extra permission, I've noticed. So you may have to work with the DBAs. Ideally, DB owner. There is something on Microsoft about the roles you need, but people have problems, and normally it's just the DB owner. But that hasn't been an issue where I've worked so far. So yeah, give them a go, and happy SQLing. All right, all the best.